All the way up from Austin, Texas. John, if you want to take it over.
Yeah, can you guys hear me okay? We'll go ahead and get going. It's always a good thing to be the last one of the day, and hopefully we get out of here and have some fun. All right, I think we're getting settled in. So I don't think we need to well, I just have to get my clicker working. Well, let's see. Oh, there we go. So you can tell right off the bat, I'm not a polished presenter like the other presenters today. We don't need to go through the AIA criteria. So I work for Terracon in Austin, Texas. We have a pretty good sized building enclosure group. I'm a senior principal. My background is a little different. I'm a mechanical engineer, graduated from Auburn, worked in the nuclear power world for about 15 years, went to work for a family business as a specialty contractor doing noise control, radio, television, studio work. Don't work for family. Ended up going to work for a roofing and waterproofing contractor for about 10 years in Texas. Great thing there is I got to see, we bid 2 or 3 jobs a week. My role was waterproofing. So you got to see several different architects' designs in detail for specifically waterproofing, worked with a lot of different contractors and trades. So in 10 years, you see a huge number of projects. You come to realize nobody really understands waterproofing. Nobody goes to school for waterproofing. So it's a very niche type thing. But I say it's conceptually pretty simple. And if you understand the concepts, you can do it. Right? But we're going to go through and talk about the whole continuous air barrier in the building is more than the air barrier in the wall. And waterproofing is a piece of that. We'll talk a little bit about the waterproofing systems, the service life warranties, relative pricing, some of the challenging details. Got a lot of photographs, talk about projects we've been on in details that we ran into, and then some about the testing methods that we use for waterproofing. I think most of the people here were architects. There were a few contractors, if I remember. Are there any subcontractors? Actually applicators of materials? Are you air barrier, waterproofing, roofing? All of them. Lucky you. And we have to start with talking about control layers. We had a lot about that. Bulk water is the one that everybody thinks about, right? Your roofing, shingles, bulk water, shed it off. Then the wall, air barrier we call, but really a lot of people will use weather resistive barrier. It's really a water resistive barrier. And then you have what I say the others. So you have the air barrier, you got vapor barriers, you got thermal barriers, right? Pretty simple concepts until we start talking a lot about them. The water vapor barrier really transports a lot of water into a building. When it condenses, it's bulk water and becomes the problem. The air can move the vapor, or the vapor can diffuse through the air and openings without any motive force of the air, or through the actual wall assembly itself. So that's why we have permeable membranes. I hear especially when we do ABA stuff in the Northeast, I think up here too, people really aren't sensitive as much as for the Texas climate, the hot, humid climates. We don't worry about cold temperature. We worry about the heat. And so we'll have a dark cladding system on the south exposure with a cavity behind it, and that water resistive barrier might be 200 degrees plus. Products aren't made for that. They don't last very long with that condition. So it's just a different concept. So I hope I don't get too much into that, because that's not applicable to you guys up here really. But here was a good example. We had a debate last night, and we've got a job in Austin that's a failed roof, fully adhered, tapered insulation, single ply, and it failed and the membranes blows up in the wind. The contractor was arguing that he put the vapor barrier down on the concrete deck, but he didn't seal it, and it wasn't an air barrier. So it allowed air to migrate up into the roof assembly. And it was really interesting from a roofer's concept. I know they worry about adhesion and not wanting moisture from the concrete deck up in the roof assembly. But from a building enclosure person, we expect a vapor barrier on a roof deck to prevent vapor from moving up into the roof assembly. And most of that comes from air movement. So it's just interesting how we talk, and we talk in general terms, but we may not really understand each other because we come from such different backgrounds. So in this assembly, right, you have the vapor barrier on the metal deck. Probably a cover board should be shown there, but so you have the vapor barrier. If it's not sealed, then it's not the air barrier. If it is sealed, it can be the air barrier. The insulation's a thermal, the roof membrane, definitely a water barrier. But if the vapor barrier is not sealed, it's also the air barrier. Right? So you got all these barriers, simple in concept, but you can manipulate how you install them so they do different functions. And what I wanted to do today was kind of talk about, when I was an estimator, I would look at a building, I was focused on all the enclosure. There's a lot of things that aren't obvious that is part of the air or the water resistant barrier. And so the green line here could be the air barrier for the building. And we try to draw it so that we have different conditions. Let's say this is a multifamily, it's low enough it could be a wood frame structure, apartment complex. Got some vertical elevator shafts. I think we put a trash chute in there. And this doesn't have to be the air barrier here, but it could be. And then you have a tunnel, right? We don't think of that being part of the air barrier, but it really is, because it's continuous, right? All the way around the enclosure. Now you're drawing a water barrier. Well, it's probably on the exterior. Doesn't have to be. It's going to include the below grade waterproofing. And here we've made a lot of horizontal surfaces. The very top of the building, typically a roof membrane, so we don't consider that part of the waterproofing. But on the patios, the lower terraces, it's like we've got an amenities deck up top with a pool on it. And then the top of the below grade garage, those traditionally are going to be waterproofing, usually adhere directly to the structure. Barrier in this case we've drawn in pretty much where the air barrier is. Could be the waterproofing, it could be the water resistant barrier too. And thermal barrier usually applies to all the conditions. Now in the south, we don't insulate below grade because we don't have frost line really. Up here you probably do. So let's say that's a balcony of an apartment complex unit. It's we said wood framing, so it's trusses going out. You've got a soffit underneath. Pretty common in our area. There's a ton of multifamily complexes going in like this, but they're really, when we do a lot of litigation, so it's a source of a lot of real water intrusion problems. but that's a waterproofing application. Low-grade walls, sort of drawn in, maybe you got a vertical airway down into the garage for ventilation. So it could be outside that airway, could be inside the airway. Got elevator pit, shafts. Before we go up to the soffit, let's just stay here. We've also drawn this where it was a open crawl space underneath. We've seen quite a bit of soil issues where we are, so there might be void forms underneath the slab, which basically go away and you have open space tied to a drainage system of some sort. But you don't think that as an air source into the building, but if you got occupied space inside, it could be a source for air to get into your building. So the under slab waterproofing. I like our young folks that graduate and they get caught up about a under slab vapor barrier. And if you've ever seen, all of them I've seen, rarely are they sealed. So they may stop vapor drive through the concrete slab, but they're not sealed around penetrations most of the time. They don't take care as they place their steel in concrete. They get holes in them. So I don't credit that for any waterproofing or air or vapor, other than maybe vapor drive into the concrete surface itself. Horizontal surface, but it's on the underside. So you've got a soffit area that may be going into a loading dock, got a couple of steps there, but you may not have to worry so much about the water barrier, but you need the thermal, vapor, and air. Amenities decks are fun, great waterproofing. If you're a waterproofer, it's great to have big decks like that. A lot of overburden, you've got the pool. Your penthouses up on the roof usually have wall surfaces into a mechanical room. If it's conditioned, then you worry thermal, air, vapor, water. The trash chutes are interesting because sometimes I go into an apartment complex and the corridors are not conditioned, they're outdoors. And they've got a shaft that goes through, but it's through the conditioned space sometimes. Well, they're not necessarily sealed. Here's probably without the basement on more of what we see as the traditional wood frame, low-rise apartment complex. And actually the units themselves are sealed, and they do air tests on the individual units, not the whole exterior envelope of the building. But when you go through the interior corridors, those decks need to be waterproofed. The walls need to have air barriers and vapor barriers. Or think about the barrier and thermal, because that's really outside. They usually have a vented attic in the roof. So the ceiling of the unit is the barrier layer. See, that's where you worry usually where the air and the vapor go together. And pretty much your thermal, because that's your outdoor, separating outdoor from indoors. Your soffits, roof line connection, here can be a challenge. Here's where you have your balconies. Your interior corridors we talked about. I just want you to think about all these areas that you may not be obvious to you need to worry about the air barriers or the outside as part of the envelope. Your below grade. So who can tell me what the difference between a waterproofing membrane and a water resistant barrier membrane is? Exactly. Water resistant barrier on the wall, used to hear it called damp proofing. A lot of times won't resist hydrostatic pressure of any sort. So in a wall cavity, if you have drainage problems, we do a lot of stucco. And a lot of the problems we see is the stucco isn't drained properly. So water penetrates the cement and the cracks and it builds up. May not be a lot, but enough inches of water pressure that it pushes itself in through the nail holes or other penetrations. Because you know, when you put your lath up, how many staples and screws they put through that WRB, right? But waterproofing is designed to withstand a lot of hydrostatic head. So below grade waterproofing membranes typically will withstand 200 to 300 feet of water in the testing they do in a lab. You don't want to challenge it that way in a field. So we want to put as much emphasis on the drainage of the waterproofing to prevent the hydrostatic head from building if we can. So basically I break up waterproofing into the below grade and elevated decks. And on the below grade, you basically have the walls, the under slab, or the top lids if it's at grade or below. The elevated decks, I think of them as terraces, which are relatively small compared to big amenity decks, pool decks. You have some elevated decks that are actually the wearing surface, so it might be top of garage over retail. Well, that needs to be waterproof. And it can either be the actual wearing surface that you drive over, or a topping slab with waterproofing underneath it. But it's got to be waterproof. When it's on the wearing surface, pedestrian coatings are not as durable as if you're going to drive over heavy vehicular traffic. And then we kind of throw balconies in there just because we do so much multifamily and wood frame. That's a whole different world by itself. How familiar are you guys with waterproofing membranes, the different types, and do you know they're there? I think architects, you know, and I'm an engineer, and one of the guy I work with that runs the office with me is an architect, and we've known each other for years. We're completely opposites, but we have fun poking at each other, right? And so, and my daughter and son-in-law are architects, and I ask them about what do they learn in school about practical application of materials, detailing, you know, and it's not much. So I sympathize with architects because you're expected to do, like Andrew, all the detailing you want's done, but is that really reasonable to expect that? Especially if it's a wood frame multifamily apartment complex and the fees, I'm sure, for the architect are small. So how do you make that work? But anyhow, back to below grade waterproofing. Basic self-adhered, post-applied, meaning after the concrete's formed and poured, membrane. A lot of people have them. They're all basically the same. They're rubberized asphalt sheet with a poly facer on it, and they have an adhesive, pressure-sensitive adhesive layer. Like most things, the surface you put it on the substrate has to be prepared right. So if you form the wall, pull the forms off, and you use a form release agent, and it doesn't dissipate, it's going to be a bond breaker between your adhesive and the waterproofing. You can't have bug holes in there because most membranes manufacturers don't want any more than maybe the tip of your thumb hole. You got to fill it. Tie rod holes got to be filled. Any fins in your forms, fins come out, you got to grind them flush. That should all be part of the concrete guy's responsibility and should be in the specification of the surface quality he has to provide. The sheet good has pretty good puncture resistance. I don't think we've talked about self-healing, self-sealing, self-gasketing, all these concepts out there about waterproofing membranes or air barriers or any of them. You know, I don't think there's any real, yes, sir. It's coming. We'll get to that in just a minute. So self-sealing, in my opinion, doesn't exist. Well, I can't say self-healing doesn't exist. Self-sealing, most people refer to a roofing nail sealability ASTM standard they test to. I think everybody agrees that probably is not very applicable to the application for walls or below grade, but it's all there is. I think we're gonna be doing, where's Laverne or Andrew? ABA has a initiative to do some more work on sealability of fasteners and what that criteria is. I'm always going to recommend a fully adhered membrane for waterproofing. And the reason for that is if you get a hole, it limits the area that water can contact the substrate. A roofing membrane, even if it says it's fully adhered to the deck, insulation, it doesn't prevent water from migrating throughout that roof deck if it gets beyond the membrane. So to me, a fundamental difference for waterproofing is it's fully adhered to the substrate. So here we go, blind side, pre-applied membranes before you pour your concrete. Picture on the right is, I think that's Salt Lake City Airport tunnel that they put in the last year. All the white underneath the steel is a waterproofing membrane. It has to stay clean. It can't have tie rod wires or any other debris on it if you want it to be fully adhered. I think if you look to the top of that picture, you can see they've already poured one section, and this slab ends up being about 5 foot thick. So you can imagine having a 5 foot rebar mat and telling the guy that right before he pours at midnight, that area down there has got to be cleaned on the membrane. It doesn't go over very well. But in reality, that's what a manufacturer expects if you want their warranty and if you want it to be fully adhered. On the left side, vertical wall, this was the Capitol Complex expansion in Austin. It's a shotcrete wall as a temporary retention wall along the property line. It's 5 stories of parking garage. You can see at the bottom of the wall, they're starting to put up the waterproofing membrane. Sometimes you'll see it done floor by floor and work around. Sometimes they want to hang the whole height of the wall at once. It's a little more efficient. But then you have to think about there's UV exposure limitations for the membrane. There have been times when the manufacturer says, I can't let you stay exposed any longer, and they'll cover it with something. Sometimes they use Tyvek, they use whatever's the least expensive to block that UV till they get to pouring the concrete. So on a blindside application, your membrane, your drainage mat goes up first, filter side out, fabric side out. Then you put your membrane on, and then the either the mechanical bond or adhesive bond side of the membrane is facing the concrete. And you'll hear that argued between manufacturers, which one is better. I personally think they're all adequate, but there's a lot of argument about a mechanical bond with like a fleece and a concrete bonds to that fleece versus an adhesive chemical type reaction with the concrete as it heats and cures the bond to the membrane. The whole idea is you don't let lateral movement of water between the membrane and the concrete. So on a 2-sided form wall, most of the time the drainage you put on after you put your membrane on, and you'll have a French drain at the bottom taking it to storm drains or daylight. For a blindside wall, you really can't do that. I can't tell you how many times especially I thought it was funny as a contractor bidding the work, they'd show a French drain at the bottom of your retention wall going out and having, well, you can't build that. So there are different drainage mats for the bottom 2 feet. Instead of a ½ inch thick, it'll be maybe 1 inch to 2 inches thick that replace a French drain but allow water to move horizontally. And then you have connection tees under your, or through your wall or under your slab to the drainage systems. So, you know, the far right picture is, I don't know what that arrow is pointing to, but there's some debris down there that had to be removed. These are guys, they forgot to pull some of the release paper off the seam tape, crawling down in the rebar cage to get that out. But those are things, those are challenges when you do under slab waterproofing you got to deal with. The left side is wood lagging. We don't see that in Austin very much. I don't know what type of retention walls they build here, but it's got to be flat and true. You'll see steel piles are down, and you'll see the vertical lines of small bolts coming through. All those have to be cut flush, and they'll take about a ½ inch step up, right? But then you have to start treating all those things poking up because that's a potential puncture source when you pour your concrete against the membrane. The gaps between the boards, they'll start off telling you no more than 1 inch. Well, it's rare when you can find one that's 1 inch or less. Usually, since you're putting your drainage mat on first, it spans that gap. Most manufacturers let you go to 2 or 3. But the concern is when you have a vertical seam and the pressure of the concrete, because if they're going to pour 10, 12 feet, the bottom has a lot of pressure on it, will push that seam open if there's a void behind it. So post-applied membranes for the walls or the top lids. We talked about self-adhered sheets. Fluid applieds can be done too. From time to time, I would see drawings drawn with a fluid applied under slab. And I was like, well, how do you do that? Right? But both cases, surface prep of your concrete is basically the same. It's got to be sound, good concrete. Some fluid applieds are very sensitive to moisture, so they may require you to have a fully cured concrete. Some can go on green concrete, but all those factor into, to me, how you choose the right product for the application and the construction sequence that you expect. The top picture is hot rubberized asphalt, I believe, although I don't see the kettle in the bucket. It may be a cold fluid. That's got a reinforcing sheet, the white sheet the guys are holding. Hot fluid has been the tried and true method, but it's sometimes difficult to put a kettle up in an elevated deck from a fire standpoint. The fire watch may cost more than the actual waterproofing membrane. So people have gone to a cold fluid. Cold fluids have been around long enough now that they're proven themselves. Some are reinforced, some aren't reinforced. We always had good success with a non-reinforced membrane, about 120 mils. It would go down in one lift, so it was a simple application. Never had any problems with it. Sometimes the spray applied, like they're putting on the walls down there, can get complicated because it may be a 2-component product, requires a special plural pump. If your guys don't use it every day, you may as well figure on rebuilding that pump if you're doing it once a month, because they don't keep it maintained right. Now you see some products that are also heated plural component items, very good membranes, but the equipment to get in the business might be $100,000. So it's hard to get that introduced into the market. Manufacturers are getting smarter now. They're renting the equipment so that you don't expect a subcontractor to make that big investment hoping he can sell the work. Then to me, there are other membranes. Picture on the left is again that airport tunnel in Salt Lake. And it's a sheet good, but it's going down on top of a fluid applied. So it's a multi-layered membrane to beef it up to get the warranty they were looking for. The right is you've seen this sort of become popular in the last 10 years, really a roofing membrane with heat welded seams. Makes a nice monolithic membrane. It may be layered with a textured material that holds not bentonite, but a polymer-based similar product that when in compression and it gets water, it swells significantly. When it's compressed in the confined volume, it gets very, very dense. It becomes another layer of waterproofing. So it's like 2 layers that you get out of it. Problem is, the waterproofers aren't roofers that know how to heat weld seams. So it becomes difficult. And if you're trying to do that on a vertical wall, it even gets to be more difficult. So, and they're very expensive. So good concept, and it's been used a lot of places. But let's say you have a remedial job, not new construction. There's an existing, let's say that it's a tunnel. Top of the tunnel or top of a basement, say 60 years old, it has coal tar pitch on it. So the cost of removing that is a lot more than a new membrane. But for the adhered products, you've got to get down to bare concrete. So these that are loose laid like the yellow membrane, the hybrids, might be the right application, even though they cost money. It's going to be cheaper for the whole picture because you don't have to get rid of that old coal tar. So there are applications where it makes sense. So that's kind of below grade. Let's move up in the air. In Austin, we've built a bunch of buildings, a bunch of high rises. A lot of them have nice, beautiful amenity decks on them, but they're a challenge. Usually pavers and pedestals over them. There'll be tree wells. There'll be all kinds of planting surfaces, the pool itself, and then the interface that goes up the wall to the rest of the building or over the side of the rest of the building. To me, the left picture is a terrace, fairly simple, fairly small, doesn't have a lot of the vegetated or water features. The one in the center was a litigation job we got involved in. It was a condominium. On the top, it had some roof decks, and it was a wood structure, and they were trying to use a urethane traffic coating on the wood structure and then do thin set and tile over it. And for a lot of reasons, it just didn't work well. But you see a lot of odd things, especially in that low-rise wood frame structures. And the right's just another amenities deck that was in Austin with a large pool and a lot of vegetation. The other elevated deck waterproofing we talked a little bit about would be, say, traffic coating, that top picture. Most of them urethanes now, you see the PMMAs or MMAs that give you extended life and more durability, but more price. You just have to factor in what's right for the project, but usually this is only where there's occupied space underneath. They don't have or don't want to put a split slab where you would do a traditional waterproofing and then a topping slab on it. That's really the most durable way of doing this type application, but half the time they don't want to, probably because of cost and schedule and the depth it adds to the structure. So here are the wood framed multifamily balconies. Sometimes you see like a fluid applied done over the wood. Usually has a drainage layer. How many people know what a T-bar is? It'll tell me if you do much multifamily. So most of the time there's a T-bar, it's 1.5 inches, pour stop basically on the edge of the balcony, but it extends down past the deck line and nails in the top, just there to pour the concrete. But the picture on the right, what we do is shim that up so there's a gap underneath the T-bar. We'll put a drainage mat down so water can, and it should be the deck sloped, so water can run under that T-bar, and then you'll have a drip edge off the edge. Then they pour lightweight concrete on top of it. And so there would be the wood frame, the wood decking, and we do metal trim around the outside. The left picture, you can kind of see the edge, the T-bar edge for the drip membrane. The right picture is an example where there was a railing post. You can see the post top left corner with the holes in the base. There was probably, this looks like it was not screwed right into the deck, but has a small metal piece that goes in the concrete pour that's bolted down, and then they put the post on top. Huge source of water intrusion because they're poking holes in the membrane, and it usually holds water right around there. And a lot of the waterproofing membranes on these type balconies are not really waterproofing membranes. So once they sit in water, they don't like being submerged. So that's a distinction to draw. Most waterproofing membranes will withstand high hydrostatic pressure in a test environment, but they're not allowed to be submerged continuously. And so in a lot of cases in the multifamily, especially in the corridor areas, they're trapped. And water is going to penetrate around the edges of the concrete or the cracks in the concrete. And once it's underneath, if it's not sloped, it's going to stay wet. The other thing I've seen is you might have a stairway in both ends of the building that say it's 150 foot long, and they may have some slope on the outer edges, but the center's not sloped. And that's when you just have the framing up. When they start loading the building with drywall, all the weight that goes in the building, I've seen where we'll put water, we have a water leak in the middle of the building. We'll put water out on the stairwell landings, and it runs right to the middle. And I think the whole structure, as it's loaded, drops, or the framing dries and shrinks up, but it affects that any drainage you might have. And once it's under the slab, it has nowhere to go, so it stays wet. Once that membrane inside there is wet, they'll find a seam that will fail because it's submerged all the time. And that's what happens. So it's really an interesting problem. Some manufacturers of sheet membrane don't care. We've worked with a company now for 8+ years, and they haven't had any problems with their balcony, and they use OSB all the time. Some manufacturers, and what you see is nobody pays attention, they want exterior grade plywood. But I've seen the reps go out and look at it, and they may or may not say anything about it not being plywood. But that'll be a discussion in a minute about warranties. Another thing about wood frame structures is when you have a soffit area and a framed area underneath the waterproofing membrane, those soffits have to be ventilated. So if you ventilate that area below, kind of back into the air barrier. So there's the white membrane on top is the waterproofing. Structure underneath, there's a soffit underneath that, so that has to be ventilated. Well, then that Tyvek around the outside isn't the air barrier because your soffit's ventilated and your trusses run back into the building. So that area on the drawing on your left side of the wall section is the exterior wall of the building. So where those trusses go back into the building, that all has to be sealed. Now, a lot of times it's a draft stop for fire protection, but it's not sealed. But then you think about, well, okay, then the units, we said this is an interior quarters or exterior space. So each unit then is considered the ceiling being the air barrier. So it's just, you got to think through where is the air barrier in these buildings. Get some more pictures of what we find when we open things up. Talked a little bit about drainage. I can't tell you how important that is, but drainage bores are a lot of different varieties, compressive strengths, and flow rates. Flow rate usually doesn't come into play. Compressive strength will if you're in a fire lane, say, sometimes in a concrete structure. Sometimes they're rated for fire trucks or heavy loads. So you have to look at the compressive strength. For vegetated areas, right, anything, we always think more than about a foot of soil could have extensive roots, and you need a root barrier. Root barrier can be a HDPE layer that's taped or overlaps significantly, or there's some drainage mats that I haven't seen this in a long time, but copper sulfate would prevent the roots from penetrating. The other auxiliary components would be termination bars, metal flashing. But you've got to look at the whole assembly and the system when you look at not just the membrane. Testing methods for waterproofing historically has been flood testing. Flood testing can be a challenge because you've got a lot of water you got to introduce. It's usually early in the construction or before they're ready to introduce a lot of water. The drain systems may not be working. Let it sit 48 hours, supposed to be observed continuously. If it's a concrete structure, I know there are leaks in a membrane, but I can't see water coming through the slab, so it passes. So to me, it was all that was there for a long time. Now we have electronic leak detection. It's either high or low voltage. It's very precise and can find pinholes in membranes. It's just a great solution to testing membranes. But there's some things about it that you got to be careful. There are some membranes, so it has to test a non-conductive membrane that's over a conductive surface. And what it does is put a voltage potential across, and where you have a hole, you'll actually get current flowing. And that's how you find your hole. Well, if the membrane is conductive, and there are some, you can't test it. If there's, like on a roof, insulation under your roof membrane, you'll have a non-conductive membrane and have a conductive substrate, but that insulation is an electrical insulator, so you can't test through that insulation. So there's some limitations, but for waterproofing, most of the time, it's the membrane that's non-conductive on a substrate that's conductive. Wood OSB substrate isn't conductive, but we're actually going to go see a manufacturer that's about 2 hours north of here that's come up with a conductive paint. So you basically paint that area. Now you have a conductive layer over the wood that'll allow you to use the LD testing. Yeah. We see it almost all the time, where we might do a dozen ELD tests in a year. We might do one flood test, maybe. Now the wood frame guys, they might do some flood testing because it is a little more obvious to see water coming through on a wood structure if the soffit's not finished. Yeah, it's. That's probably where we're going tomorrow. Yeah. It's far superior. I would make it a mandatory test for any waterproofing membrane myself. Well, careful with that. Now you can, if done right, go back and retest later to find leaks, but with or without overburden, sort of. There are other monitoring systems that are still, I think, pretty expensive that will actually monitor and tell you remotely where the leak is on or within a grid pattern where the leak is. So on a vegetated roof or a big amenities deck that has a lot of overburden, there's some benefit to that. But you don't see those very often. I have no idea how I'm doing with time. 10 minutes? Here's a job in Houston. We did some flood testing on it. It was just a mess. There was a bunch of different compartments. There was a cold joint in the slab, and there was a point that leaked forever, and we could not figure out where the water was coming from. And the poor waterproofer redid it 2 or 3 times. I know he lost money on the job. But it finally stopped. But it was just a long, drawn-out process. That was the crack underneath. This was, the left picture was a terrace above it. They had finished it, didn't test it, and it leaked. And they had pavers and pedestals up there. It took a long time to figure out, but it was hard to rent the space when they had water leaking. So there's the ASTM standard for the electronic leak detection. I don't want to get into a lot of the details. We talked a little bit about a non-conductive membrane, a conductive substrate, and the ability to conduct the current through to find the hole. The low voltage system uses 2 probes. You have to wet the deck, have a perimeter isolation wire, and you take the probes and kind of triangulate to the leak. And what you're doing is finding where that current flow is going. On the right, you'll see that metal, sort of like a broom or squeegee. It's the high voltage, basically has 30,000 volts or so that looks for holes in the membrane, but it's done on a dry membrane. What we think is nice about that is most of the time the waterproofer is with us. We can detect areas that are too thin or have holes. He can repair that while we're there, and before we leave, we'll retest it, we're done. Where if it's a wet test, he can't do much until it dries out. This is some playing around with the high voltage system. So a non-conductive surface on a conductive substrate, put a hole in it, and I mean, it can find a pinhole, but that's the type of arc you get. This is a case, top left picture or top picture, single ply membrane over polyiso on a conductive substrate. We put a hole in and we couldn't get an arc. We put water on it a little bit, couldn't get an arc. Filled the hole up where it was really wet, then you can get an arc. So to say you can't test a single ply over insulation isn't true. It has to have enough moisture to conduct that current. Part of the reason we're going to go visit this place tomorrow is they have ways now they think they can test single ply over insulation. For a roof system, that's a great thing. Just talking about overburden, right? Those pavers and pedestals, if you're not familiar with them, they look something like that, or they're stone. Those happen to be wood. The picture on the right is a courtyard in San Antonio, an old building. Redid the roof, and we knew this was going to be an issue. We tested the roof, did a water test, and didn't have any problems. Then they went and put vegetation. If you can see the top of the picture, they used a tray system of vegetation over it. Within a year, they had all kinds of leaks. And There's actually a sacrificial layer, additional layer of single ply just to protect the true membrane from the trays. But it was tough because it was hard. This was before, and I was working as a contractor then, wasn't aware of the electronic leak detection. But I'm pretty sure there was enough water under that in the insulation. You could have gone and done a low voltage test and found it. I think there are people that probably with the vegetation in place might be able to go test and find where the leaks are. So it's just an interesting concept. Unfortunately, I haven't been able to try it on that area. I don't know what they ended up doing with that. Just real quick, this will be in for you to look at, but service life and warranty is a different type of materials. I would say all this is probably some dated material, but probably still pretty true. But I want you to understand how many people think a labor and material warranty means the manufacturer's on the hook to fix the waterproofing membrane, including the labor cost associated with it. That's what I used to think. Really, it's just the limitation of the cost he has to put into the repair is based on the original labor and material cost of the project. So material warranty is only the material costs, labor and materials. It's not like a roofing warranty where they'll use the terms no dollar limit. You don't see that in waterproofing normally. So the good thing about specifying a high extended warranty is it will require the manufacturer to say, okay, if you want that, here's some additional layers you have to do, or heavier membranes, or you get a better quality product probably. But don't think it's going to protect you so you never have a problem. These are dated, but I think the relative costs are probably true between the different type of waterproofing. So yeah, this is probably 6 to 8 years old in pricing. So some of this may be double that now, but I think relatively speaking, they're probably in the right order. And I think that's it. So I don't know if that was something you learned from. I like waterproofing because that's what I do. Do you guys have questions, or my contact information's at the front? Yeah.
Just a general question. I've seen, hundreds of podium decks waterproofed over the years, and you're talking about drainage. 99% of them I go to are dead flat.
Yep.
And so, you're talking about providing drainage, but then every one is dead flat. So, and if you look at the material absorption properties of asphalt membranes, they underwater absorb a ton of water weight.
So if you end up in a situation where you can't have a sloped deck, or you don't have enough drains so that you're not running 50 foot to a drain, because 1/4 inch per foot, that means every 4 feet's an inch. So 48 feet would be 12 inches of rise run. Most people can't afford that. That's why you end up with a flat deck. But then you better talk to the manufacturers you're specified and make sure they're good with a flat deck roof. Because inevitably there's going to be ponding on that roof, and there are areas that are going to stay wet forever. But usually when we get involved, the structure's done. No, we're not putting slope in that. Yeah. But it's important. Slope and drainage. Anything else? We really have enjoyed it. Thank you.
Thanks, John. Much appreciated. Thanks everybody for coming out today. Hope to see you next month in October for our next CBEC meeting. Do you have something to add?
Yeah, I don't need Mike. Just wanted to thank you guys for having us. It was a great turnout, great conversations. Thank our manufacturers that are still here. Say something to them as well. And give us all this about their support. So we got lots of other presentations. We'd love to come back sometime, maybe this year, next year, whenever. Let us know. And we'll
Thanks again. If you guys could help us just by getting the trash and recycling into the right containers, we'd appreciate it. Have a good afternoon.